All right, today we're going to break down the GLM-5 paper from Zhipu AI and Tsinghua University. This introduces a new flagship foundation model, and it's one that's been engineered from the ground up specifically for agentic AI. We're going to get into the core technical contributions and see how it stacks up on the benchmarks, where it's setting a new state of the art. Okay, let's just zoom in on this one phrase from the abstract because it really frames the entire ambition here. Vibe coding. What does that mean? Well, you know the feeling. It's that trial and error process of just throwing prompts at a model, tweaking them, and hoping for the best. GLM-5 is all about moving past that toward a much more disciplined, reliable, and engineered approach to building AI agents. So to really get what they've built here, we first need to understand the fundamental problem the GLM-5 team was trying to crack. The paper points to this huge bottleneck we're all seeing with large language models. The real challenge, the big leap, is to get these models to go from being these, well, super smart but kind of passive encyclopedias that just answer questions, to being active, autonomous problem solvers that can actually execute complex, multi-step tasks out in the real world. And this is a really crucial point. They didn't just make a bigger model. GLM-5 was engineered from the ground up to smash through these specific barriers. The research zeroed in on the insane computational cost of training and inference, while also making the model way more adaptable to the kind of dynamic, real-world tasks you'd see in software engineering. Okay, so how did they do it? Let's dig into the core engineering pillars that make GLM-5 tick. And we'll start with how they actually train this thing. What you're looking at is this multi-stage pipeline, right? It's a progressive thing. First, you've got this absolutely massive pre-training phase. We're talking 27 trillion tokens. Then they do this mid-training step to stretch the context window way out to 200K tokens. After that, they bring in sequential reinforcement learning to sharpen its skills. And the secret sauce that holds it all together, this technique called on-policy distillation, which is super clever because it lets them refine the model without it forgetting all the good stuff it learned before. So the first big pillar here is the architecture itself. GLM-5 uses something called Deep-Seek Sparse Attention, or DSA. Now, what this does, and it's pretty slick, is it lets the model dynamically focus its attention resources where they matter most. The upshot? They can scale this thing up to a whopping 744 billion total parameters while actually cutting the computational costs for both training and inference. That's a huge deal. Now, this is where we get into some really cool in-the-weeds engineering. They were using this thing called multi-latent attention, which is great for speed and memory, but it was lagging a bit behind another method, grouped query attention. So what did they do? They invented this technique they call muon split, which applies matrix orthogonization to the attention heads. By making sure each head learns something unique and non-redundant, they completely close the performance gap, as you can see right there in the table. All right, pillar number 2 is all about the infrastructure. You see, with these long, complex agent tasks, standard reinforcement learning can leave your GPUs just sitting there, idle. It's super inefficient. So what they did was engineer a totally asynchronous system. They basically decouple the part that generates the actions from the part that learns from them. This lets them just constantly churn out new data, which means way better GPU usage and a massive speed up for the whole RL pipeline. And that new infrastructure sets the stage for the third pillar, which is all about the algorithms. The team developed brand new asynchronous RL algorithms designed specifically to learn better from these super long multi-step trajectories. These are what really sharpen the model's ability to plan ahead and correct its own mistakes in complicated environments. And this is a really practical feature, for actually using the agent. GLM-5 has 3 different thinking modes you can choose from. You've got interleaved thinking, where it kind of thinks out loud before every action, which is great for following instructions. Then there's preserved thinking, which helps it remember its reasoning across multiple turns, essential for those long-haul tasks. And finally, turn-level thinking gives you fine-grained control to balance performance with latency. Okay, so we've seen the engineering. It's impressive, but the real question is, does it work? Let's look at the numbers and see how GLM-5 actually performs on some of the toughest benchmarks out there for agents, reasoning, and code. First up, we've got the Artificial Analysis Intelligence Index. Now, this isn't just one benchmark, it's a meta-benchmark that pulls from 10 different evaluations. And as you can see, GLM-5 is right up there in the top tier, hanging out with the biggest proprietary models and cementing its place as the new king of the open-weight models. Yeah, and that score,
50? That's a really big deal. Why? Because it's the first time any open weight model has ever hit that mark on this index. It's a huge step forward in closing that gap between the open source world and the closed proprietary systems.
And it's not just on synthetic benchmarks. Over on El Marina, where you have millions of real people judging the outputs, the story is the same. GLM-5 takes the #1 spot for open weight models in both the general text arena and the specialized code arena. That's a huge vote of confidence from real users. So, how do you test if a model can think long-term? Well, the team used a benchmark called Vending Bench 2. And this is pretty cool. It tasks the model with running a virtual vending machine business for a whole simulated year. To succeed, it can't just think one step at a time. It needs a consistent long-term strategy. And the result? GLM-5 ended the year with over $4,400 in the bank, making it the #1 open source model on this task. This really shows it has a solid grasp on long-term planning and managing resources. When it comes to writing code, GLM-5 is an absolute beast. It's putting up state-of-the-art numbers. And get this, on the SWB Bench multilingual benchmark, it actually beats some of the big names like Gemini 3 Pro and GPT 5.2. That's incredibly impressive and shows just how good it is at complex software engineering. Okay, let's pull all this together. We've seen some incredible architectural, algorithmic, and performance wins. So what does this all mean for where AI development is headed? One thing that really drives home that engineering focus is how practical they've made this model. It's not just a research paper. The team did deep optimizations for 7 different mainstream Chinese chip platforms. This means GLM-5 isn't just powerful in a lab, it's actually deployable on all sorts of hardware, and it even cuts costs.
So when you put it all together, GLM-5 really feels like a paradigm shift. It manages to deliver that cutting-edge performance while also being computationally efficient enough for real-world use. It's laying down a whole new foundation for what agentic AI can be. And by making this model open source, the goal is pretty clear: to get it into the hands of researchers and developers and push beyond just chasing benchmark scores. With this kind of agent capability now widely available, the really exciting question is, what new kinds of autonomous AI applications is this going to unlock? Where do we go from here?